Okay, I think we are ready to start the seminar. So, welcome everyone here. I'm Marieke Plugmakers. I'm the editor of All About Feed, and I'm really happy to be here and to see you here, all of you. So today in this seminar we talk about feed efficiency, and for sure nowadays it's an important topic with the high feed prices and the uncertain market nowadays. So therefore, of course, it's important to get everything, the most, out of every kilogram of feed. And today we have 4 experts that will dive into this topic and tell us all about feed efficiency. Before I will welcome the first speaker to stage, I'd like to address that it's possible to ask questions. We will have time for questions after each presentation. So when a question comes into your mind, just save it for after the presentation. And also welcome to the people who are joining us via the live stream. You can ask questions via the chat box. However, we're not able to answer them during the seminar, but the speakers will get in contact with you if you have a question. Or a contact person of the speaker is in the chat to answer the questions right away. Okay, so I think then we are ready to go and start with our first speaker, Julia Hankel of the University of Veterinary Medicine in Hanover. She came by bike, she said to me. So, and in her presentation she will talk about how facial bacteria will tell us how much feed the pig needs. So let's give a warm welcome to Julia.
Hello everybody, yes, you can hear me. I was not the only one coming by bike here, so there were much other bikes, not so much, but yeah. So, thank you very much for the introduction and also for the invitation. I'm very glad to be here and to be able to share with you some of my thoughts on feed efficiency and on intestinal bacteria. And right at the beginning of the speech, I wanted to give you an example because I'm always reading a lot of studies, and some of those studies I think are very interesting for us too. Most of the studies are for humans, are done in mice as animal models for humans, but some of those studies are about obesity. And I think those studies might be interesting for us when it comes to fattening farm animals. And there's one study, what did they do? They searched for a pair of twins, one obese twin over several years and another a lean twin, and they took feces of those twins. And those feces they fed to mice. It's called fecal transplantation. It's only simple said. And so they had 2 groups of mice. One got the feces of the obese twin, and the other group of mice, same genetics, received feces of the lean twin. And what they observed was that body weight did not change in mice of the second group of the mice that received the feces of the thin twin, the lean twin, but those mice that received feces of the obese twin gained weight, and they had a massive change in body composition. They had a massive increase of fat in their bodies. And they offered to both groups the same feed, the identical feed. There was no difference in feed intake between both groups. The only difference was the fecal samples offered to those mice, and so the bacterial composition of the intestines in such mice. I think you have never thought on feed efficiency in this way, but I think it's quite an interesting study, and I would like that you keep the study into your mind for later. Okay, feed efficiency is quite easy to calculate. It's feed consumed and growth achieved. But behind this quite simple ratios, there are a lot of informations. Of course, diet is a major factor influencing feed efficiency, and especially energy content of the diets, but there are also internal factors as well as external factors. So we have variabilities in maintenance requirements, we have different growth rates of the pigs, we have different activity levels, of course, thermal environment plays a role, health, of course. And with this study in your mind, I told you at the beginning, I think there is another factor that has to be considered, and this is intestinal bacteria. Almost every surface that is in contact with the outside world is colonized by microorganisms. There are bacteria, there are viruses, there are fungi, and so on. So every membrane, we know also the respiratory tract, so our lungs are not sterile. Our eyes, the skin, the urogenital tract, and of course the digestive tract. There are many, many microorganisms. The highest density we find, of course, in the digestive tract. And not only the highest density, we also find the highest diversity. So in humans, we know that in our digestive tract, we have about or up to 1,000 different bacterial species. In our nose, about 40 different species. On our hands, about 200 different bacterial species. And all this assemblage of microorganisms in a defined environment is called microbiota. Perhaps you have already heard this term. And all those microorganisms forming such a microbiota are very, very individual. So every person, every pig, every animal has an individual composition of microbiota, like an individual microbial fingerprint. And it is possible to match, for example, cell phones to their owners only because of the fingerprint, the microbial fingerprint we leave on our cell phones. The same works with our partners too. If you have a physical close relationship to your partner, like as you have to your cell phone, it works. We can match partners together, only because of the microbes we leave on our environment. So not only microbiota differs between individuals, it also differs between anatomical sites. This is what you can see on the slide here. So microbiota composition of the small intestine differs greatly from microbiota composition of the large intestine. And something very important to know is also that microbiota composition is dynamic. It is subject to various influences, like beginning the host genetic, the environment, the diet, of course, disease, stress, drug treatment. There are many ways of coexistence between the host and the microorganisms. And one is called mutualism. That means that the host and the microorganisms are living together and benefit from each other, but they do not depend on each other. And this is quite the situation we have with our microorganisms living in our gut. Again, as an example on mice, if we raise mice in a sterile environment, they develop a normal phenotype, almost normal. They are a bit underweight, interesting too, but they are alive, they are viable. So we do not need our microorganisms to live. But if you transfer those mice in a non-sterile environment, they will get ill very quickly and they will die because they cannot cope with infections. They have an only underdeveloped immune system. So microbiota are very important for the development and the training of our immune system. They have protective function. They protect us from invading pathogens. This is also called colonization resistance. And what they also have is a metabolic and a trophic function. So we have many anaerobe bacteria living in our gut that are able to degrade otherwise indigestible polysaccharides. And they produce short-chain fatty acids. And such short-chain fatty acids are, simply said, an energy source for the host, of energy that would be otherwise lost, of course. And this is the reason why, we can speculate that microbiota composition and growth performance of pigs or obesity in humans are connected. And science has already proved this connection. And I would like to show you some of those studies. This is one of those studies. And what you can see here is that the researchers were able to cluster a group of pigs due to their microbial composition in feces, nothing else. There is a cluster of red pigs with a different microbial composition to the blue pigs in feces. And if you compare daily weight gain and body weight, final body weight, we call it final or body weight at slaughter, then they saw that there are significant differences between both clusters of those pigs. So pigs that had a microbial composition of the red cluster were at the end 850 grams heavier and had an average daily extra gain of about 18 grams compared to pigs of the blue cluster. So microbial ecosystems measured in feces are somehow related to growth traits in pigs. The same, almost the same here. They could also cluster samples due to, according to microbial composition in fecal samples of pigs. And what they saw was that enterotype C, or cluster C, differed from cluster D in back fat thickness. So there is also not only a connection between growth performance and microbial ecosystems, also between body composition and microbial ecosystems. This is a study very interesting for me as nutritionist as well. There is also a link between microbial ecosystem and digestive efficiency traits. So the digestibility coefficients of energy, of organic matter, of nitrogen are linked to microbial composition in the intestines. Of course, it is difficult to distinguish about cause and effect. So are we just picturing a situation in the gut with the bacteria we measure in feces, or are the bacteria in the gut drivers of growth performance? However, what is important to know is that there is a connection. And I will show you why this might be important. The current concept of phase feeding is based on average nutrient requirements, right? And our pigs, we are keeping them in groups. But our pigs have individual body composition, individual growth rates, they have an individual feed intake. But we design our feed on the average feed intake, on the average growth rate. What if we could identify those pigs that are prone to a fat layer or that are slow growing? We could feed them more individually. We could consider their individual requirements, but we have to detect them. If we are able to detect and to identify them, we can change feeding for them, and this would be change the feeding to a resource efficient feeding, because we could reduce the feed offered to those pigs, those slow growing fat prone pigs. And this would be, of course, a sustainable feeding. But we have to identify them. We have to detect them in a barn. And there are also ways to classify pigs according to their body composition, via means of ultrasound examination, for example. So we measure the diameter of back fat layer and the musculus longissimus dorsi underneath this back fat layer. It works. We have done this before in studies. But from all I have said now, from the whole, we can also may use in the future fecal bacteria composition to be able to identify pigs that are good in utilizing nutrients, that have a high growth potential. I think this is my last slide. Yeah, this was my last slide. Thank you very much for your interest and for your attention, of course. And I'm looking forward to your question that I hopefully can answer. I think the main skill will be my, the main risk factor is my English. We will see.
Oh, you will do fine, I think. So thank you for your presentation. And we have some time for questions, so if there are any questions, now it's time to raise your hand. No? Then, oh, there's a microphone. Yeah.
Is this difference in microbial composition can be for animals in the same farm? Like statistically, could it be like the same farm having different microbial compositions? You said it's about the environment, so they are in the same environment, but they develop different microbial compositions?
Yeah. Back to this example I gave before. They used such mice, grouped not in the same boxes, cages, and saw such different in body weight development. But if they rearrange the groups and put every mice together, they develop, or the obese mice lose weight. So there is a change of bacteria when they are living in the same environment. Of course, when we measure one barn, we do not see such great differences in microbial composition as we would measure two different barns. But still there are differences. And those studies are over many barns, as there are many animals, many pigs, but we have done studies in one barn and we see differences. We see differences, it's quite the same study, I haven't published it yet, but it's quite the same study you saw in the last slide. There are differences between pigs of different growth performance and different body composition in diversity of fecal bacteria. And I can see those classifying in these four groups: high performing, or with a growth rate, and a different body composition. It is able, also we can do this.
Thank you. Other questions at the moment? No? Then I have a question for you. So, is there a link between this knowledge that we have and what we saw in former times when antibiotics were used in feed?
Yeah, it's a time when I was still at school. But yes, there are not many studies on that, because this method we use here, the 16S ANA analysis, was not available this time. But if we think about what we know, what antibiotics do with microbial composition in our intestine is what they should do. They kill bacteria, they prevent growth of certain bacteria, so we have a reduced density and a reduced diversity. And if we think about bacteria as also competing, not only as energy giving, but also competing with nutrients that we eat, they compete with the nutrients we eat in our intestine. So if we have a lower density, we might think about having much more nutrients available for us. And there's a second point. Our immune system costs energy, and if we have a lot of bacteria in there, also pathogens make part of our microbiota as well, potential pathogens. And activating always our immune system costs energy, costs protein, and if we have a lower density and a lower diversity of microbiota, this might serve or save energy. Only against this background we have to think also about, I'm always thinking as veterinarian on diseases and high diversity and colonization resistance and such, but we can think also the other way around.
Okay, thank you. Thank you for now. And so let's give a big round of applause for Julia. And then it's time to move on with our second speaker of today. And I would like to welcome Tobias Steiner. He's product manager at Phytobiotics. And in his presentation, he will discuss how to improve the FCR and the performance in commercial pig production. So, welcome, Tobias.
Thank you, and welcome everybody. Good afternoon. Indeed, it's my pleasure to present to you about how we can support feed efficiency and performance in growing finishing pigs. But I will not be presenting to you a classical feeding experiment that we've done. I'd rather show you a specific method, a statistical method, how we can monitor performance in a commercial environment. So, let's jump right into the topic with something that everyone knows about. So on the left-hand side, you just see the importance of feed. Because this represents to you the portion of feed cost in total pig production cost in different countries. And on the right-hand side, we can see the development of the feed prices. So obviously, and I know this is not new to anyone here, the more expensive feed becomes, the more weight this has on the whole pork production. And this is not only for pigs, it's about 2/3 of the cost is feed cost in almost all species, sometimes even more. But let's have a look at practice. Our animals in commercial practice have to have a very good feed efficiency to keep them healthy, but also in sustainability terms, of course. But these animals are under challenge due to the impact of various stressors. And these stressors can be environmental or feed-derived or from microbial origins. And what they do is to disrupt gut health, gut integrity, compromising digestibility. And that, of course, goes with inflammation, with oxidative stress, with a loss of digestive capacity. The result, of course, is an increase in feed conversion ratios and a higher susceptibility of the animal for disease. So potentially medication cost can be going up as well. Now, as said in the beginning, I'd like to point out how we can use botanical feed additives, because Phytobiotics, we're a developer of botanicals. And there is plenty of literature nowadays to describe how such botanical compounds supplemented into diets for all kinds of animals can work. I will not focus on the mode of action today. But what we want to achieve with such botanical supplementation, obviously, is to minimize the impact of these stressors in the commercial practice, hence supporting feed efficiencies and keeping medication costs as low as possible. So I'm talking about the IQs. IQ stands for isoquinoline alkaloids, so that is a specific specific compounds of botanical origin that we can use in all kinds of feeds. And what you see here are just the different performances that we have collected from various trials all over the world. You can see the averages over there, like an 0.5% effect on feed intake, 3% in gain, and almost 3% in feed conversion. These are averages. But on the right-hand side, you can easily understand, as these are the individual trials behind those averages, there's lots of variation in such data. And this is a difficulty because with high variation, it's very tricky to predict how a feed supplementation with such products will really influence the productivity in the commercial real world. And in fact, it's really a trial dilemma, as I would call it, because on the one side, of course, we can make scientific experiments. These are very well controlled, very highly standardized. We can make sound statistics and really draw scientific conclusions from these experiments. But the downside is they do not really represent the real world out there in the farms. So if we want to know how a specific product works in real world conditions, we can run field trials. But field trials come with a downside too, because they're hardly standardizable. Statistical evaluation and analysis is almost impossible in many cases, because there are so many influencing factors, right? But this is what counts for the farm owner, for the manager, for the producing business in the end of the day. So what can we do? We want to know how these things work in practice. And we've been using a methodology called statistical process control. Statistical process control, or abbreviated as SPC, allows for running tests, trials in the commercial practice, thereby utilizing big numbers of animals. That means we have a lot of repetition, and repetition is what we need to draw appropriate conclusions. We can take consideration of all the variable factors that are there in the commercial practice, like genetic variation of our animals, changes in feed composition, changes in the health status of animals. This can all be considered by the SPC method, and we can even have control groups versus treatment groups, and most importantly, we can run a statistical analysis with such data. And for those who are interested in knowing more about SPC, this is one of the papers which are available in the literature, just briefly showing you in a picture what the principle of this SPC is. You please consider this is a commercial production. Each batch or production batch is a batch of pigs going through that production. And on the y-axis, you are monitoring performance parameters: gain, feed conversion, medication cost, whatever you want. And you can see the dotted lines. Within these dotted lines, you find all the performance records of your pig batches. And in the middle, of course, you can calculate an average, but the average doesn't matter too much here. Important is that there is variation, and there is intrinsic variation of this particular process. And this is indicated by these upper and lower control limits. So what we are interested running an SPC trial is those data points, those batches that are outside of this normal variation of that process. Because then we can say this is really having a significant change in your process, because it's not part of the normal variation. That's about the principle how SPC works. And we've tried that in a commercial production environment. So we went to Spain and found a partner there, a pig integration in the north central part of Spain, who was using their genetics, their own feed. Pigs were originating from about 20 breeding farms. The feed was coming all from the same feed mill. And we made two periods that we wanted to compare to each other. The first one is the control period. And you can see that this control period included data from 2017 up until 2021. And there was no supplementation in that feed. The second period was the experimental period. In this period, we fed these isoquinoline alkaloids, supplemented them into the feed. And well, while the second period, the experimental period, was about 140,000 pigs, the control period was about 2.4 million of growing, finishing pigs. In this area, they're raising the pigs to 120 kg of live weight. And you can imagine that gave a very, very big data set. We collected all the performance parameters, and these were subjected to a cluster analysis based on feed compositions, based on health statuses, etc. And the global results are presented now in the next two slides. So you can see, first of all, the SPC analysis between the control and the treatment showed no difference in feed intake. There was no difference, same feed intake more or less. But in average daily gain, we found approximately 4.3% increase, and we found 5% reduced feed conversion of all those pigs running through that process when this botanical supplementation was implemented. Mortality, there was no change detected, although there was a storm hitting this area in Spain in January 2021, but mortality and runs were not influenced. However, we saw a statistical difference in medication costs, which were 30% lower due to respiratory diseases, due to digestive disorders, of course. Yeah. So, significantly improved gain and feed conversion and less less medication cost. So this is a very global picture, and we can even run a very brief economic calculation to that. Based on those savings in feed cost and medication, you can see that by saving feed cost and applying about 260 euros per ton of feed, this means about 3.59 euros saving per pig just in feed cost. The saving in medication cost was about 40 cents. Of course, we have to deduct the cost of adding this compound to the feed, which is about 60 cents per pig. But this gives you, in real life conditions, still a very solid saving per every single pig. Now, we said, okay, that's a very interesting data set, but we wanted to put this under challenge a little bit, because we said, okay, the control period was very long. There might have been some genetic progress. Although the SPC normally takes this very well into consideration, we wanted to know, okay, what happens if we pull the product out of the feed again? So we extended this analysis, and I'm just showing you the feed conversion results now. So you can see the first period, control before. We also used less batches. We just took data from 2020 onwards. And we could see, you pull the IQs in, you put the IQs in, feed conversion is going down, as seen in the last slides. But when we pull them up, feed conversion ratio is going up as well. So that confirms also to us the validity of the SPC, really to monitor the performance under commercial conditions. So this is a way that we made it for the first time, because we really said, okay, all our scientific trials are very, very good. They give us very important information. But how does this really work under practical conditions? And that's why we made a statistical process control trial as just presented to you here, with improvements in feed conversion, in growth rate, etc. And this is something that can be used for all animal species, right? Making an SPC in broiler chickens or in sows, in layers, can be done very well. You just need the right tool to make this. And with that, I'm a little bit faster than I thought. Thank you for your time, and I'm happy to answer your questions. Thanks a lot.
Thank you.
There's one question.
Yeah, Sophie has the microphone.
Hello. My question was that when you ran the commercial trials, maybe you had mentioned it, but were the batches from the same farm, or were they a collection of multiple farms?
They came from 20 breeding farms.
Um,
It was, yeah, but you know, as the pigs came.
right.
But it
No,
was
but
from
the
20 defined farms.
right. The finishing portion was only on one farm, or was it also on multiple?
No,
farms?
it was on multiple.
Okay.
It was on different sites.
Okay. Thank you.
Yeah. So you have that variation factor in your system too. It's all about handling variation. Yeah.
Other questions? Yeah. There.
With the factors you're using for SPC, are they allocated before you apply animals to treatments versus control, or is it something you look at later on once you've got the data and therefore allocate those factors?
I'm not sure I got your question precisely.
Yeah,
Sorry.
That's okay. So you're doing genetic variability,
Yeah.
health
Yeah.
events or status. Are they,
Yeah. Okay.
are you allocating animals randomly for control and treatment based on that, or you're just looking at the data once you get it
Got
in?
your
and
point.
yeah.
Thanks for that. No, you can't allocate this upfront. You have to analyze your data that you get and cluster them into these different segments afterwards.
So how do you know if you're, how do you determine after the event if you've got a representation in both groups for those factors?
Yeah, well, you have to have this, I wouldn't say it's a randomization, but you run all the pigs through the same farms. The easiest thing to control is probably the feed composition. The health cluster is already a little bit more tricky, but it's just the size of your, or the number of your batches that guarantees you that you have a vital comparison with, and you make the cluster analysis afterwards, and you can analyze all these parameters that I just showed per cluster.
Okay.
So in fact, you do have all your pigs in those different clusters. And if you don't have one cluster with both your control and your test, you have to discard this cluster.
Right, thank you.
Thank you. Any other questions in the room?
Can you please get back to the slide where we were talking about before and after using phytogenics? Yes.
This one.
Yeah. Just to understand a little bit about this intrinsic variation where you're explaining here, I can see that there is odd points that are coming out of the intrinsic variation in both before and after using phytogenics. However, things are more controlled within the phytogenic part in the middle. And what's the reason for this? I feel like these kind of points are questioning a little bit that statistically might be here the number of forms are more, and then the part in the middle where the control experiment was, like the number of points are actually less, or maybe the farms that you are experiencing in the middle are less number of farms than the ones on the right and the left.
It's of course a shorter period. You can extend such test periods as long as you want, frankly speaking, but I think it's mostly the fact that it's a shorter period that appears to having less spread of the data points. But indeed, maybe it is also a way of, stabilizing gut integrities, stabilizing or improving digestibilities with such products that brings your variation down. Could be, yeah. But this would be a bit too far-reaching from that data that we got. Yeah. I guess it's a visual effect that you're seeing. Yeah. But statistically, it's significant.
Okay, I think for now I'd like to thank you, Tobias, for your presentation and answering your questions. So big applause for Tobias. Thank you.
Thank you.
And then it's already time to move on with our third speaker of the day, Karel Vervaat, and he is Senior Product Specialist at Best Mix Software. And in his presentation, he will talk about software as a driver to boost feed efficiency. Welcome to the stage.
Thank you. So, also on my behalf, thanks for joining this presentation. I think I will be a little bit the odd one in the seminar, speaking about software and how this can help you to boost efficiency. I will skip the agenda because time is limited, so we will, and I will skip also my part in the presentation. But I will try to explain you how software can help you, because we hear a lot of science, we hear a lot about trials, and everybody is explaining that compound feed and the feed that you feed and the feed efficiency is very important. Well, software really can help you, and I will share with some examples from our experience. I will share with you how software as a solution can help you in getting that result. First of all, the first topic I would like to address is having a lot of data. We hear about big data sets to do statistical analysis. We hear about that you need a lot of information. But also when you look at feed formulation or when you look at ration advice, because feed efficiency is all about feeding pigs, feeding cattle, feeding poultry, feeding all species, then you need a lot of information. What we saw in the past in software, everybody's running around with his local laptop with all the information on the local laptop, visiting farms, collecting a lot of information and keeping it on the laptop. Or if you wanna start analyzing your data, if you wanna see which farms perform well, which farms perform worse, what is the feed conversion ratio, what is the average daily gain on the different farms, no matter what species we're talking about, well, having a cloud solution, having software that can grasp that data, that can give you insight on your entire customer base, or whether it's locally or globally, because if you're a global player, then you can have information about United States, about Europe, about Asia. It doesn't really matter where you are. A cloud system will enable that, will give you the possibility to group information and to share that with the business. So what we did is we introduced the cloud concept, where you do not only have the software available in the cloud, but also all the science and all the data is also available in the cloud. So that in the end you will get a collaboration between product management, sales advice, feed formulation. So everybody involved in the entire chain of getting the feed up to the animals can work in the same environment, can share knowledge and information. Because in the end, what we want to do with software, we want to turn the science, and we will hear a lot about science today and in the next coming days. Yeah, in the end, we have to make it practical. The science, the research that is performed by universities, but also by the major players in our industry. Yeah, we need to get that science into software so that we can turn it into feed, that we can define requirements for the animals. Because if we achieve a certain feed conversion ratio, okay, we need to have feed that will accomplish that. If we want to have high-performant cattle, if we want to have high-performant poultry, doesn't really matter. Yeah, all that science, that's available. It's called animal modeling. Well, having a tool where you have a very flexible way of integrating the knowledge, the research that you are doing, integrating that into software, without too much fuss, without too much hassle, online, immediately available. As soon as you enter it into the software, people in the field immediately can apply it in their daily work. Yeah, that's just a huge advantage. You don't need years and years of software development, of of cooperation with companies like ourselves and so on. No, you want to make sure that all that knowledge, it gets integrated immediately in the software. So what we do is we take all the knowledge from the industry, we put it in software, we talk to our customers, and the knowledge they have, we apply it. We amend the industry standard models, we apply it to the local needs, because like Tobias also explained, yeah, when you go in the field, yeah, it's different than what you do in the research. In research, everything is pretty well standardized, but as soon as you go into practice, then you need to tune, then you need to tweak the research to the practical cases. Well, we do that in software, and we apply all the industry standards. Doesn't matter whether it's for cattle, and we have an entire list here of everything that we have available for animal modeling. And animal modeling is, of course, what you need to get the correct ration. But this modeling, these available models that you have, yeah, you need to be able to tweak them. So what we do in our software is we give people tools, we give people the possibility to tweak. Yeah? So take the CNCPS, take NRC. We have a new model a new dairy cattle model came out last year. What you see here is just our software, okay, we don't have a pointer, so I will just try to point a little bit higher, where you see that you have an editor, where, let's say, the scientific knowledge that was put in by our team of developers, yeah, it's not a black box. It's not you put in the performance figures of the animal, you hit the button, and in the end you get the outcome from the model, which is let's say in most cases for software, that's how it happens. No, we give our users, we give them insight. How does the research work? How was the research? What is the effect of feed conversion ratio, of energy requirement? What is the effect of milk production or fat body weight gain, and so on? What is the effect on the requirements of the animal? And what are also the predictions that come out of that? Yeah? It's all tweaked within the software, and you can consult and modify it yourself. Also something very important, something totally different, but also again coming from the research and making it practical, is enzyme modeling. Yeah? Enzymes are there to use in a more efficient way phosphorus. Well, a lot of companies we know, or before they started using our software, before they started using Bestmix, they were using phytase or other enzymes at fixed rates. They say, okay, we apply them at a certain rate because we know it works. But if you want to do it correctly, you want to apply the science into your software. So we added the ability to apply or to integrate the entire effect of for instance, phytase into the software, so that when you start formulating using phytase, that you do not get an overdosage of phytase, which, well, it's cheaper than today than it was in the past, but still it's quite an expensive component of your feed, and still you only want to use as much as you require, so that in the end, we keep the planet safe by not applying too much phosphorus in our feeds. Another example of what you can do with software to make your feed more efficient. Again, turning practice or making use of practical information on farm is the integration with quality control. Feed formulation typically is all about theory. I think Julia was also explaining, we are calculating with average figures. If we take the quality of wheat, the quality of corn, the roughage, whatever we are using in our feed formulation, it's all average values. That's very nice, but it's not accurate. That means that the feed composition you are calculating based on those averages is just wrong. Yeah? So the closer you have it integrated with quality control, the closer you have it integrated with the samples that are taken either on farm or that are taken either in the feed mill at the raw material intake. Well, if you have an integrated quality control where every sample that goes into the feed mill, or where every sample that is sampled on farm with a handheld device or sent to an external lab, whatever, if those values they are sent back to the formulation tool, either for the feed formulation or for the ration advice, that's how you get more and more into a situation where you are going to use accurate figures at the moment where you really need them. So you're working with real life information during ration formulation. So this is just an example where you see you have a number of samples, but what we do is that during ration calculation, you have the ability to immediately deep dive into the details of the raw material quality. From the raw material, deep dive into the available samples that were sampled via quality control, and then, let's say, recalculate and recalibrate your raw material quality based on those figures. Because in the end, that's what you need. You want to work with real life figures, not with the theory, because with the theory, you're giving a wrong advice, and therefore, this will lead to feed inefficiency. You will not work or you will not process or, let's say, help the animals in the most ideal way. I think it was Julia as well that was mentioning, what if every pig could be fed an individual diet? Because if we could analyze every individual pig, then we based on their the microbiology in their feces, we could really make them more efficient if we would know, if only we would know. Well, here, digitalization and of course the digital transformation that is going on, everything is measured these days. We have run projects where we do key performance monitoring, or the KPIs, we monitor them on farm. This was a project that we did in Canada, where for dairy cattle, individual animals during the milk control, milk production was measured, milk fat, milk protein, and so on. And all this information was gathered in an online platform available for our software to be processed. And if you then have the individual performance figures of each and every individual animal, well, then the next step, of course, is very easy. Then you want to do an individual cow-based ration advice. Because how efficient can you be? Instead of, let's say, grouping all your animals into averages, we have the mid-lactating cows and the high-lactating cows and the low-lactating cows. No, we have a cow that produces 40 kilograms of milk, 39.8, and another one 37.3, and so on. If you know for every animal what she does or how she performs, you can feed them individually and therefore become more efficient. So that's exactly what we did. Within our software, we have a tool where you can import all those KPIs. And then you see for every individual animal, you see milk production, milk fat, milk protein, how long is that animal into lactation. And then during the formulation, you will see that top right, balanced material, you see that the concentrate that needs to be fed to every individual animal is processed here. Of course, as a farmer, and again, that's not feed formulation, but then you go into technology and to the on-farm housing system and what is all possible for in feeding robots and so on. You need to be able to process that information. But in my opinion, how much more efficient can you be if software will allow you to feed every individual animal to its exact needs? And of course, I'm not going to say if you're running a pig farm with 20,000 pigs, I mean, individual farming is not possible probably, but an average of 20,000 is also maybe not the way. So we have to see whether there are somewhere measures in between that we can really start grouping our animals based upon the KPIs that we monitor. The whole industry and the on-farm machinery is, there are so many sensors and so many measurements made. We should start making use of those measurements. And software here obviously can help you. Last part of my presentation is feed efficiency. Okay, it's all about the feed, of course, and we want to make the animals perform in the ideal, in the most optimal way. On the other hand, we also have to think about the planet. Sustainability is becoming more and more a topic these days. So when you talk about feed formulation or when you talk about ration calculation, until now it was always minimizing cost. Because minimizing cost is what we really want to do. We want to have the cheapest feed possible, of course, returning, let's say, the necessary nutrients that the animal requires. What we have done now is we have integrated a third component. So we had already cost and nutrition. That's part of any formulation tool. I mean, that's not only Best Mix, let's be honest. Every formulation tool has that. But we now also incorporate environmental impact into the optimization. For that, we work together at this stage with BASF, where let's say, based upon the diet that you feed to the animal, we have a direct connection to the environmental calculation, and we can include into the optimization how much of the price, how much relaxation or how much price increase we allow for getting a more sustainable feed. Yeah? Because it's not all about feed efficiency. I think also sustainability in the future will play a bigger role. So how you design feed makes a difference for the environment. So that means that during formulation, and I'm having here a feeding program of fattening pigs, where on the top right figures you will see climate change, water usage, eutrophication figures, and so on, that are calculated by the Optienix platform from BASF, but that we want to include, or that we can include in the whole optimization. Yeah? And as such, of course, we try to bring you the best of two worlds. So that's, on the one hand, we try to have a price optimal feed, and on the other hand, we also want to consider the sustainability impact on, let's say, the impact on the environment. So these were just a couple of examples of how software can really help you in being more efficient with the feed that you deliver to your clients. So that was it for me. Are there any questions?
Thank you. Thank you very much for your presentation, for your talk. Are there any questions at the moment? I don't see any hands. Oh, there. Yeah.
So if I understood it correctly, next to the data you collect and optimizing it and analyzing it, it's also a formulation tool that farmers can use.
Our software.
Yes.
Yes, it's feed formulation and ration calculation. So we try to combine all the information in one piece of software, because in the end, the ration advice results in feed production. Because the advice that you give is there to be able to sell the feed that you produce. So we combine it in one tool, and then the data that we collect on farm is, let's say, is basic information for the ration calculation, and therefore it all goes into the same tool. So we collect the data on farm. Out of that, we calculate the ration advice using any model you like, and out of the ration advice, then you start doing feed formulation with labeling, with, let's say, going to production and so on. So it's fully integrated.
Thanks.
Other questions? Yeah, Sophie.
Just on the ration balancing, you showed various models,
Yes.
CNCPS, NRC, and you mentioned how you could, or a user, I guess, could go in and modify equations.
Yes.
What is the benefit of that? And I guess the reason I ask is these models are developed based on research and then validated, with users then modifying the biology, what happens then to the predictions and the quality of the predictions.
Yeah. What's the benefit? Well, the benefit is that you can. It's not that you have to. But what we see is that we have quite some customers that say, okay, if we have software that is purely based on CNCPS, we see that for certain races, for certain kind of animals, on the high performing animals or on the low performing, we see that's, whether it's now CNCPS or NRC or CVB, doesn't really matter, that the figures are slightly off. What the model predicts does not represent what we see in practice. Yeah? And then you have the ability to modify it. But I agree with you. I mean, why would you change CNCPS? I mean, there's years and years and years of investigation and research done. But still, we see that a lot of our bigger customers, a lot of our bigger customers, they do research, and it's not only about changing a commercial, or let's say changing a model that is an industry standard, but also to be able to apply your own knowledge. Yeah, if you say there are certain figures that are not calculated by any of the commercial models available, and we want to have the ability to calculate a prediction, a certain performance figure. We want to add another input parameter to the ration calculation that is not foreseen by any of the models. Well, in our tool you can. Yeah, it's open. You don't have to. Yeah? And well, a lot of our users, they see that as a huge advantage. Not that they have to, but that they can.
So just to clarify, are most putting new biology in, new predictions,
Yes.
or are they modifying existing?
Doing both. But of course, Yeah, again, I'm not the expert in ration calculation. I'm more the expert in software. We teach them how and what they put in. That's their business, but they can. Yeah, and it's immediately, and that's again, it's an open system. You don't need a software developer. You don't need us. So you can do it yourself. We just train you, and you enter the biology yourself.
Thank you.
Okay, I think then it's time to move on. So, Karel, thank you, and a
welcome.
big applause for Karel. Thank you. Our last speaker, I'd like to welcome Deepak Dubey, Senior Product Manager at Choline, and he will discuss choline nutrition for efficiency-linked sustainable dairy farming. Welcome.
Thank you, Marike. Well, first of all, a very warm welcome for attending this seminar. And also thank you for Karel, because somewhere when you touch upon dairies and also sustainability and the efficiency, this is giving me a good platform to talk about the dairy, and we are moving from monogastric to the dairy side. So, well, cow health is linked with efficiency, and the efficiency is linked with all three pillars of sustainable dairy farming. So, when we look at all three pillars of sustainable dairy farming and how health is connected, if you see that cow health is compromised, it will not only affect the productivity, but also it will use feed, land, water, and the time resource, which is very precious. So in next 15 and 20 minutes, I would like to bring your attentions towards optimizing cow health as a foundation for sustainable dairy farming. So when we look at productivity, in relation to the greenhouse gas emission, the data from 1960 says that the greenhouse gas emission was carbon dioxide equivalent was 2.18 kilograms per kg energy corrected milk, which has gone down to 1.18 kilograms per kg energy corrected milk yield. So that's a significant reduction. We have to look at the greenhouse gas emission from the point of energy corrected milk yield. And one more additional thing which data says in last 50 years is that livestock emission per kilogram of energy corrected milk yield has reduced. So efficiency is the cornerstone for a sustainable dairy farming. So that's where it's very important that we look at cow health linked with efficiency. Now, cow health is a very big topic, actually. So what I would like to say that managing the metabolic health during transition phase can take the first seat, as it sets the tone how well the cow will perform through the lactation cycle. So that's where the return over investment and sustainable dairy farming can be seen. So that's all about how do we see the transition phase. Now example here is published in Journal of Dairy Science from a commercial farm setting where a cow, when she did not had any metabolic disorders in first 21 days postpartum, she produced 10,453 kilograms of milk. But when the same cow had one metabolic disorder in first 21 days, she lost 357 kilograms of milk. And when the same cow had more than one metabolic disorders in first 21 days post-calving, she lost 703 kilograms of milk. So quantifying the problem is also very important. And not only production, but also reproduction too. So time taken for pregnancy and the calving percentage was significantly reduced, and also that resulted into the culling percentage, which was higher. So what I would like to bring your attention is towards the importance of transition phase and optimizing the metabolic health during this phase. So this is a very classical graph you would have seen that metabolic health is linked with a negative energy balance, because when the energy output is higher in milk than energy input, she compensates with her body reserves, and that's where this all things starts. So negative energy balance, when we looked at based on our when we evaluated commercial farms, we found two things. One, that more than one metabolic disorders were present in the commercial farms, and second, one metabolic disorder, for example, here ketosis, is whenever the peak of ketosis was higher, there was a time when the metritis peak was also higher. So they are interrelated. Now, a negative energy balance is linked with clinical and subclinical ketosis, and that's where when we looked at the how relevant and how big this problem is in today's context. So we looked at systematic review and meta-analysis published by analyzing 27 publications, says that the range of ketosis is 9.6 to 63.3% in current context. So going forward, when we looked at the data from European condition, how relevant this problem is at subclinical level, so 10 European countries says that 23.6% is the subclinical ketosis, which is tip of the iceberg, because the whole iceberg of having metritis, subclinical ketosis, and displaced abomasum was also interrelated with subclinical ketosis. Now, this is also a very classical phenomena where the cow, when the fat mobilizes in the form of NEFA to the liver, and when the liver is unable to handle the fat for the ATP generation, and then that leads towards ketone bodies formation. So that's the productive fat which got turned into negative fat, which we say ketone bodies, and the solution is for formation of VLDL, very low density lipoprotein. Unfortunately, ruminants are not having that kind of genetics still to synthesize the VLDL formation by themselves. And the solution for forming VLDL by the dairy cows is through supplementation of choline, because choline is an integral component of VLDL, and research data says that whenever choline was fed to the cows or ruminants, it reduced the fat burden on the liver. Not only that, but the regular cycle of fatty acid metabolism through the beta oxidation to generate ATP also require carnitine, and carnitine synthesis is also interrelated with the choline supplementation. This is one of my favorite slides, because when I present here in 15 and 20 minutes and talking about choline, probably this is one where a meta-analysis of last of 21 experiments ranging from 1984 to 2018 says that whenever the choline is given to the cows, it improved the milk, energy-corrected milk yield by 1.7 kilogram, and also significantly improved the efficiency in dairy cows. So to feed choline, you have to give rumen bypass or rumen protected as well as intestinally digestible form of choline. So with this, I will say that Cameron has brought CholiGem, which is where the cow meets health. It's a second generation of encapsulated choline from Cameron. It has got more than it has got 60% choline chloride, which is unique because most of the products are coming in with 25 to 28% of choline chloride, and comes with more than triple the bioavailability in CholiGem. So one of the unique model which Cameron scientist has developed is CQ model in CholiGem, and CQ model is nothing but the 3 C's, which comes with starting own material. So what Cameron has done is that we developed our own choline chloride, and then we coated with the scientific coating, not too hard, not too thick, but a perfect scientific balance, and added the physical characteristics of specific gravity and particle size to ensure the rate of passage for higher bioavailability. So this is a CQ model, comes with CholiGem to ensure the greater efficacy from the product. The qualitative analysis, because more than double the concentration, triple the bioavailability, also gives the benefit of 2 to 3 times reduction in water and carbon footprints in the manufacturing. At this stage, we are also going deep dive into LCA calculations for the manufacturing of CholiGem. So then we went to the universities. University of California has studied CholiGem performance, and 21 days before calving and 21 days after calving, when CholiGem was given to the dairy cows, this is the photos, also having primiparous and multiparous cows into the study says that multiparous cows improved milk production by 1.3 kilograms during the supplementation period, and 3.5% fat-corrected milk yield by 2.1 kilogram. So this was during the supplementation period, but when legacy effect was seen, it was still continued after 21 days of supplementation. In case of primiparous cows, they did not show in first 21 days. They may be doing something else. We are exploring the uterine microbiome data and all with the primiparous cows, but during first 90 days, they also improved the milk production. So this is where we are still, this research is continued. But initial number says that the feed efficiency improves with choline nutrition. This is the topic of the day. So that's why I wanted to bring this information here. But also what we say for subclinical ketosis, that was also reduced when the collagen was given to the cows. We also went to the farms because this is equally important, that university setting information is one side of the story, but when we go to the farms, we have a different kind of management and factors which also need to be considered, and also see that how product performs in the farm setting. So in this case, we had a farm in Belgium where we have 230 multiparous cows farm with the robotic milking, and we had collagen and the control group. Here in this case, 14 days before calving and 40 days post calving, collagen was given to the cows, and milk production which we have seen in this research is 1.3 kilogram in first 40 days when the supplementation was given. But after that, when we had the time to have see the legacy effect, it was also 800 gram in first 90 days in milk. So the return over investment can be calculated not only on the short-term basis, but also mid-term and long-term basis. There's one calculation software gives, is the standard peak production, having the different factors of the farm, considering age, days in milk, lactation number and all. And then they compare control versus treatment. And in this case, collagen improved 2.7 kilograms of milk in this farm. The reproduction, we had the chance to have the reproduction, to see the reproduction performance. And in this case, 55 days less open days was until pregnancy was seen in collagen group, and also the 24% less insemination was needed in collagen group when cows were given choline. And also the culling percentage was reduced something like 40%. We had the chance to check the BHB label also in first week where it is a standard. We found that the BHB level was more or less same in both control and the collagen group, but when we digged deeper into to see different cows, we found that collagen group had no clinical ketosis, whereas in case of control, it was 13% cases of clinical ketosis. In case of NEFA, it was similar, and BCS, it was similar in both type of cows. We had one more farm where we studied, we increased the duration of not 40 days, but 60 days postpartum. In this case, when we fed 60 days collagen to the cows, we find that that the milk production was improved by 1.6 kilogram. And interesting thing here was that we had a chance to have entire lactation cycle. And in this case, 1.6 kilogram was consistently maintained, and or we say lactation persistency was very good. So having a 300 energy corrected milk yield of 305 days, it was 1.6 kilogram milk which was produced by the cows in the lactation with collagen, and also the standard peak production was 1.9 kilogram milk as compared to control group. So the ROI is decided by how do we see it, short term, mid term and long term, looking at the milk production, also the reproduction and the culling rate, and different calculations are there where we see that if you invest €1 on the choline nutrition, you get 4 to 8 euros as a return over investment. So I am very much in 15 minutes almost. And then this is my last slide, where Coligem, a breakthrough innovation in choline nutrition, has raised the bar for higher performance from ruminant animals by providing the superior bioavailability of choline in cows, along with greater flexibility for application with green food printing. Thank you very much.
Thank you. Any questions? No, no hands. Okay, I have a question.
Yeah.
So, how essential is it to feed choline to cows? Like, is it an option or
Yeah.
is it needed?
Well, very good question. So during transition phase, when different metabolic pathways are going through, and we say homeostasis, like fat mobilization is always there from the adipose tissues, and then this fat is coming to the liver, and we see that that the fat, which is NEFA, is not properly utilized, and this is where the evidences are there. So I will say that this is a phenomena of homeostasis, which is always taking place in dairy cows, and to utilize all the NEFA which is coming to the liver, that's very important that we take care with choline. So this is one side from the metabolism side. But on the other hand, the one slide which I shared, where meta-analysis is done for 21 research experiments. So that was not from the farms, but these all the experiments which were published in past, when they were analyzed and seen that cows are producing 1.7 kilogram of energy corrected milk. So with this, I'm very confident that this is not optional, rather a mandatory concept for all such kind of cows, all the cows at the farm.
Thank you. Thank you for your answer. Any questions? Okay, then I'd like to thank you, Deepak, for your presentation. So a big round of applause for Deepak.
Thank you.
Thank you. And that brings us to the end of this seminar. Before we close, I'd like to share something with you. So I'm excited to announce that we are hosting a new edition of the All About Feed Forum next year on the 7th and 8th of June, and it's hosted in person. Last year we hosted it online via the online platform, but now it's possible to have in-person events again. So I'm really happy to share this with you, and the program will announce very soon on the All About Feed website, so keep an eye on that. We will also talk about feed efficiency and sustainability, so I hope to see you there. And for now, I wish you a nice day at EuroTier. Thank you for being here. Thank you, of course, to our speakers for their presentations and sharing their insights with us on this important topic. See you next time. Thank you.